Okay. Um, Another disturbance to the change to the allele frequency of a population would be non-random mating, where organisms may prefer to mate with others of the same genotype or of different genotypes. Non-random mating won't make allele frequencies in the population change by themselves, even though it can actually alter the genotype frequency. So this keeps the population from being in the Hardy-Weinberg equilibrium, but it's debatable whether it counts as evolution, since the allele frequencies are staying the same. But however, it can actually it's still considered as one of the factor that can actually makes a population not to be at equilibrium, right? Um, Again, this is the blister beetles that I talk about in my previous video. So they actually prefer their partner to be the same size as them. So what I know is that they are kita ada big size and small size. So the big ones, they like to partner with the big ones, and the small one, they like to partner with the small ones. So this is non-random mating sebab ada preferences. Also we call this associative mating lah. See, black and black, grey and grey. Sorry, I just macam simplify kan ikut colour je. But actually homozygous dominant, they like to partner up with the homozygous dominant. The homozygous recessive, they like to partner up with the homozygous recessive. In compare to the disassociative mating, they don't care. They can mate. They actually tak kisah the homozygous dominant doesn't mind to be partnered with the homozygous recessive and so on. So this is if this occurs randomly, so this is random mating. But if it's actually occur sebab dia memang tak nak dengan AA, contoh macam homozygous dominant, dia memang tak nak couple dengan ni, dia nak dengan ni je, and itu dah kira non-random juga sebab dia ada preferences. A random mating should occur randomly, tak ada preferences, dia terima seadanya. Okay, kalau itu yang jodoh dia, itu jodoh dia lah. But in non-random mating, dia nak jodoh dia to be a certain specific characteristic yang dia nak lah, right? So something like that lah, right? So that's non-random mating. Natural selection. So finally, the most famous mechanisms of evolution. I talked about this a little bit in the previous video, but just let's go through it one more time. Natural selection occurs when one allele or combination of alleles of different genes makes an organism more or less fit, that is able to survive and reproduce in a given environment. If an allele reduces fitness, so if an allele that can actually reduce the fitness of that individuals or organism, its frequency will tend to decrease from one generation to the next generation. So again, this is what we meant by, you've heard this a lot of times, survival of the fittest. So kenapa dia survive? Sebab dia fit. Kenapa dia boleh fit? So something about dia punya genetic composition yang allow dia to be the fittest. So kalau that alleles membantu dia untuk survive, then that allele will be more increased in the next generation because it will be passed on to the offspring. But if the allele reduces fitness, its frequency tend to drop from one generation. Okay. Again, selecting the trait that are most fit. Inilah dia, survival of the fittest. Frequencies of A is 0.3, recessive allele 0.7. X has been eaten by the bird. Kenapa they are eaten by the bird? Probably because they don't have the capability to survive it. Okay. So in terms of this case, dark rock environment, light grey beetles are spotted and eaten by birds more often than the dark ones. So we have two phenotypes. Basically, we have the dark rock phenotype, and then we have the light grey phenotype. So this is rocks. Okay, so the color of the rocks is almost the one that have the dominant allele. The phenotype of the skin is somehow makes them able to camouflage in the dark rock environment. the light grey, not so much. So the light grey will be eaten by the bird because they are easily spotted by the birds. So this beetle, they will survive. So when they survive, they reproduce. When they reproduce, there are more of them as compared to the grey beetles. Okay, so this is survival of the fittest. Natural selection lah. Ada positive selection, ada negative pressure. Now, why the observed and expected phenotype frequencies can differ? These are the types of selection that can occur in nature. Okay, so we have directional selection, we have stabilizing selection, and we also have destructive selection. So this first situation, it favors one tail of distribution. One tail, okay? One tail tu masuk hujung ni. Ni adalah, okay, you belajar statistik kan? So ni kita panggil dia distribution graph, right? So directional selection means it favors one tail. Satu side je distribution yang dia favor. Perhaps the tallest, perhaps the shortest, but not both. So dia one extreme straight. Maksudnya dia fokus dekat, kalau I tengok dekat graph kat sini ialah dia favor the long tail. So that's why you nampak graph dia ke sana. Short ni macam tak ada, right? So directional. Therefore one extreme trait, not both. So sama ada long atau short. So in this term dia pilih long lah. Okay, so dia ke arah yang longer tail. So these cicak, they actually prefer their tail to be longer because they look like snakes. Bagus untuk dia punya predating activities lah. Okay, but maybe kalau directional selection tak semestinya ke sana, dia boleh je ke sana juga. Okay, let's see, dia boleh je ke sana. Okay, maybe the extreme trait that they, for another organism that they choose is to be short, not to be long. Depends lah the kind of organism tu. So it's either selection against one extreme means kita ada dua phenotype, for example dua trait, in this case long or short. So dalam graph ni dia tunjuk dia prefer yang long. So yang lagi satu extreme tu, yang short tu dia tak ada, dia nak yang long saja. And medium ni maybe ada sikit lah, right? So this is directional selection. And then imagine that the both tails of distribution are selected against, and only the middle is favoured. So now kita nak untuk stabilizing selection, dia actually prefer moderate traits. Dia tak nak short yang extreme yang negatif, dia tak nak extreme yang positif, dia nak yang medium. That's why you nampak graph dia macam ni, distribution dia macam normal. Okay, so contohnya macam these cats. Short tails actually mess up the cat's balance, and the long tails actually drag on the ground. So medium tails are the best. So it depends on the organism, right? And then imagine that the extremes on both ends are favoured. Maksudnya dia nak short, dia nak long, dia tak nak medium, not so much. So you dapat this like a camel humps punya distribution. So selection for both extreme but against a moderate trait. Short tails for tupai help keep predators from catching you on the ground. Okay. And then long tails are also good for the balance on the trees. Medium tails doesn't help so much. So that's basically the types of selection that occurs in nature. Okay, make sure you know these types and what they actually stands for lah.